In this work, we will prove Thales' theorem, which says that wherever you choose a point M on a semicircle like this, having AB as diameter, this triangle will be right at the point M. So how we will prove it? The first thing is we will draw this line from M to O. And here we have this distance OB is equal to this distance OM is equal to this distance OE, since it's a circle. Now let's prove that this angle is right. For that, we will call this angle X. So here, since this triangle is isosceles, also this angle will be equal to X. We know that angles in a triangle, in an isosceles triangle, are equal, the opposite angles of the equal sides. And here also, if we call this angle Y, this angle also will be equal to Y. This triangle also is an isosceles triangle. Now let's write our sum. We know that the sum of angles in a triangle is equal to 180 degrees. So here we have this angle X plus, and this angle is X plus Y, X plus Y, plus this angle X plus Y plus this angle Y is equal to 180 degrees. Here we have it's equal to X plus Y plus Y. Of course, it's equal to 180 degrees. Here we have 2x plus, and of course here 2y. 2y is equal to 180 degrees. And of course here we have 2 as common factor, so we have 2 times x plus y is equal to 180 degrees. And of course from here we can just divide by 2 here, so x plus y is equal to 180 degrees divided by 2. That means that x plus y is equal to, here 180 degrees divided by 2 is 90 degrees. So here we have proven that this angle x plus y is equal to 90 degrees, meaning that it's a right angle. So here we have proven that the triangle EMB has a right angle at M. And this, of course, concludes this work.